Okay, so yesterday we learned adding and subtracting numbers in scientific notation, and my exponents have to be the same before I can add and subtract my decimal values. All right, so today what you're going to see, we're doing 4 problems, okay, total. That's all we're doing in this part of the lesson. We're going to do 4 problems, and with all 4 of these problems, the exponents are not the same. So I cannot simply just add those decimals together and be done with it. I have to make my exponents the same first, and then I can add. So how do I do that? Well, the first thing you need to do is you need to decide which exponent value is smaller. Which exponent value is smaller between the two? Okay, so go ahead and write this down. Write down both sets, actually. Go ahead and write down both sets. All right, and then that's what you need to be looking at when you're writing them down. The first thing I want you to notice is which set has the smaller exponent value. That's going to be really important in getting them to be the same value. Which one did we say was smaller, -3 or -2? Which one is smaller? -3 is smaller. It's farther from 0. So this is the one we need to change. The other one that has the larger exponent stays exactly the same. All right, so I'm just going to rewrite it. 3.41 times 10 to the -2nd power. I rewrite the one with the larger. Now, the one with the smaller exponent, I need to figure out how many do I need to add to this value to make it match my larger value. How many would I need to add to -3 to make it equal to -2? 1. So because I am adding 1, remember what we learned yesterday. If I'm increasing my exponent value, I move my decimal to the left that many places. So now to write an equivalent scientific expression, it would be 0.82 times 10 to the -2nd power. Okay, so I increased my exponent by 1, and that moved my decimal to the left 1 place. And now that I have the same exponent in both sets, now I can add them together. 0.82 plus 3.41, and I can add them together now. Okay, so go ahead and finish it up. Okay, do y'all agree? 4.23? Okay, times 10 to the what? Times 10 to the -2nd power. All right, okay, so now on the next one, I want you to decide which set of scientific notation is going to have to change. Okay, you look at them. Which set needs to change, the first one or the second one? Based on what I just told you on the first one. The second one. Why does the second one have to change? Because it has the smaller exponent. So that means on the first one, I'm going to rewrite it. Okay, I'm going to rewrite it. And now on the second one, I have to figure out how many I have to increase my exponent by to equal the larger exponent. And I want you to write that number next to the exponent. What you think. Okay, write a plus and how many you think. How many is it, Faith? 3 plus what equals 5? 3 plus 2. So I need to add 2 to my smaller exponent to make it equal to 5. Do you see that? So however many I increase my exponent by, what's happening to my decimal? Which way? To the left. I move it left 2 places. 1, 2, and now I need a 0 placeholder. So it's going to be 0.072 times 10 to the 5th power. 0.072 times 10 to the 5th power. And now that I have, so my whole goal was to get my exponents the same, and now that my exponents are the same, I can add my decimal values together. All right, go ahead and get the rest of your answer. 772 times 10 to the 5th power. 10 to the 5th power. All right, one more slide. Okay, now the only difference here is we're subtracting. We still have to do that practice of getting our exponents to be the same value. Okay, so for both of these, you see that you have different exponent values. You cannot subtract when you have different exponent values. You have to make them the same first. Okay, so go ahead and write these down. And then what I want you to do is try to figure out or pick which set needs to change, and then move your decimal. So which one has, on the first problem, which one has the smaller exponent? -6, okay? So that means that my first set, 2.8 times 10 to the -5th, doesn't change at all, okay? That's ready to subtract. But my second one, I can't subtract yet because how many do I need to increase -6 by to make it equal to -5? 1. So if I need to add 1, what does that tell me to do to my decimal? Move it to the left 1 place. 0.16 times 10. Guys, don't write -6 here. You just moved it. So now it's -5. Now you're ready to subtract and write your answer. Go ahead and do that. Yeah, when you subtract, guys, 2.8 minus 0.16, what has to be, when you're subtracting, what has to be over that number?
0.
A 0. If you don't put a 0 over the 6, you're not going to get the right answer. All right? And then when you subtract, it's supposed to be 2.64. Okay, so 2.64 times 10 to the -5th power. Wait, did I subtract it wrong? You had to borrow. The 8 borrows to a 7. 10 minus 6 is 4. 80 minus 16. 80 minus 16, 64.
Why did you subtract?
Because there's a subtraction sign between the sets. Whatever sign is between the sets, that's what you're doing with the decimals. If there's a subtraction there, you subtract. If there's an addition, you add multiplication or division. The multiplication signs in the middle here are just showing scientific notation.
Why do they say borrow, like with the 8 and 10, right?
You have to borrow. You can't do 0 minus 6.
Why do they say borrow when you're not giving it back?
Dude, don't.
I mean, for real.
Okay, let's do the next one. Raise your hand when you have the answer. I know a couple of you already have it. Go ahead and do the next one, and we'll wrap it up. Which one do we need to change? The first one or the second one? Second one needs to bump up by how many? By 1. So that tells me that I have to move my decimal left 1 place to make it 0.24 times 10 to the 3rd. Now that I have my exponents the same, I can do 4.5 minus 0.24. Don't forget, Aaliyah, did you remember your 0? Okay, you cannot do 0 minus 4, so borrow 6 to 4.26 times 10 to the 3rd power. All right, who got it right? Okay, so I want that many people getting this question right on your quiz on Monday. Okay, or more, because we still weren't at 100%, but that was really good. Okay, and if you understand that, that's everything you need to know for 8.7 and the rest of chapter 8.